Some breakthroughs sound so perfect that they trigger a different reaction: disbelief. A battery that charges in 5 minutes, lasts over 100 years, costs less than lithium, and breaks every known limit of energy density. But when experts looked closer, they didn't see a miracle. They saw something that didn't add up. Donut Lab didn't just announce a new battery. They announced what sounded like the final answer to every problem electric vehicles have ever faced. According to the company, their solid-state battery delivers up to twice the energy density of today's lithium-ion cells. That alone would be enough to reshape the entire EV industry. But that wasn't even the headline. They also claimed the battery could charge from 0 to full in just 5 minutes, essentially matching the time it takes to refill a gas tank. No more waiting at charging stations. No more planning trips around plugs. Then came the lifespan. Donut Lab says the battery can survive 100,000 charge cycles. To put that into perspective, even charging a vehicle twice a day, every single day, the battery would still outlive the car itself by decades. And somehow, it doesn't stop there. The company insists this battery works reliably in extreme temperatures, from freezing winter conditions to intense heat, without losing performance. It reportedly contains no cobalt or nickel, two of the most expensive and controversial materials in modern batteries. That would make it cheaper, cleaner, and easier to manufacture almost anywhere in the world. Fast charging, extreme durability, ultra-high energy density, low cost, mass production ready. In battery science, these advantages usually cancel each other out. Improving one almost always makes the others worse. But Donut Lab claims they've eliminated every trade-off at once. And that's exactly where the excitement turned into unease. Because when a single technology promises to solve every limitation at the same time, the question isn't whether it's impressive, it's whether it's even possible. And the deeper people looked, the harder that question became to ignore. Everything about this story begins to unravel with one number: energy density. According to Donut Lab, their solid-state battery reaches 400 watt-hours per kilogram. Not in a lab experiment, not in a distant prototype, but in a product they claim is ready for mass production. That figure immediately raised eyebrows across the battery world. Today's best lithium-ion batteries, including those used in high-end electric vehicles, typically fall somewhere between 175 and 250 watt-hours per kilogram. Even after decades of optimization, that range represents the practical ceiling of commercial battery technology. Yet Donut Lab says they've gone far beyond it. More than that, they claim this extreme energy density exists alongside ultra-fast charging, an almost permanent lifespan, low cost, and simple manufacturing. In battery science, that combination is almost unheard of. Even industry giants like Toyota, Samsung, QuantumScape, and CATL, the largest battery manufacturer on the planet, have spent tens of billions of dollars chasing solid-state breakthroughs. And despite all that investment, they're still struggling with fundamental problems like stability, durability, and scaling production. So when a relatively small startup suddenly claims to leap past everyone at once, experts naturally ask the same question. How? What materials are being used? What kind of cell architecture makes this possible? What trade-offs were accepted? And that's where the first major problem appears. Donut Lab hasn't explained any of it. No material details. No design disclosures. No technical breakdown. In battery development, energy density never comes free. Pushing it higher almost always means sacrificing something else: safety, lifespan, cost, or manufacturing complexity. But Donut Lab insists there are no sacrifices at all. High energy density, 5-minute charging, 100,000 cycle lifespan, low cost, easy mass production. For many experts, that wasn't confidence. That was a warning sign. Because when the most important number in battery science is presented without proof or explanation, skepticism isn't negativity. It's common sense. And soon, that skepticism started spreading far beyond engineers. If Donut Lab truly had the battery they were describing, there was one place where doubts should have instantly disappeared: CES. This is where companies don't just talk. They show working prototypes, live demonstrations, real measurements. For a breakthrough battery, even a small functional cell would have been enough to silence critics. But that didn't happen. At CES, there was no charging demo, no discharging test, no equipment measuring energy density. No visible working battery cell of any kind. What visitors saw instead was an empty battery casing. That detail matters more than it sounds like. In the battery industry, companies guard formulas and internal structures closely, but they almost always display a functioning prototype. Even unfinished technologies are shown operating at some level. A real battery, even a small one, leaves no room for doubt. An empty shell does the opposite. It suggests the technology either isn't complete or doesn't perform anywhere near what's being claimed. And then there was another inconsistency that people quickly noticed. Beneath the CES display, the energy density wasn't listed as 400 watt-hours per kilogram. It was 350. That might not sound like a huge difference, but in battery science, it's massive, especially when the original number was the foundation of the entire hype. If the technology was real and measured, why was the most important figure already changing? For many observers, this was the turning point. CES was the perfect opportunity to prove everything. Instead, it raised more questions than answers. The claims remained bold, the language remained confident, but the evidence was nowhere to be found. And once people started asking why, the story took an even more uncomfortable turn. Once the technical doubts began piling up, attention naturally shifted away from the battery itself and toward the company behind it. Because when a breakthrough is real, the organization delivering it usually looks a certain way. And Donut Lab doesn't. On paper, Donut Lab is a very young startup, registered in Estonia, with a reported team size of around 9 people as of late last year. That number alone raised serious questions. Battery development, especially at the level Donut Lab is claiming, is one of the most complex engineering challenges in modern science. It normally requires large, multidisciplinary teams working across materials science, electrochemistry, mechanical engineering, and industrial manufacturing. Major battery companies don't operate with handfuls of people. They employ hundreds or thousands of specialists, often spread across multiple research centers, running experiments for years just to improve performance by a few percentage points. That's the reality of battery innovation. What makes Donut Lab even more puzzling is who those 9 people actually are. Based on publicly available information, only one team member appears to have a background directly related to battery or materials science. The rest come from fields like sales, marketing, startups, software, and project management. Those roles are important for building a business, but they are not the foundation of a revolutionary energy technology. This creates an uncomfortable mismatch. A company claiming the biggest leap in battery history, with almost no battery scientists on staff. That alone doesn't prove deception, but it does make the story extremely unusual. And the questions don't stop there. The spotlight then moves to the face of the company, its CEO. Marco Lamacchi does not come from the battery industry. He doesn't have a background in electrochemistry, materials research, or energy systems. Instead, his career spans a wide mix of creative, media, software, and startup ventures. That kind of background isn't inherently a problem. Many successful tech leaders are visionaries rather than engineers. The issue is pattern. Just months before unveiling Donut Lab's solid-state battery, Lamacchi publicly claimed that another company he was involved with had created the world's first true artificial superintelligence. According to those statements, the system was supposedly fully autonomous and more powerful than all existing AI models combined. It was an extraordinary claim, but it came with no product demonstration, no technical documentation, no peer-reviewed research, no independent validation. After a brief surge of attention, the project quietly faded from public discussion. When critics place that episode next to the solid-state battery announcement, a troubling similarity emerges. In both cases, the narrative is the same. World-changing technology, massive implications, confident public statements. And yet, when it comes to verifiable proof, there is very little to examine. This doesn't automatically mean Donut Lab's battery isn't real. But in technology and science, credibility is cumulative. Each claim adds weight to the next. And when previous claims collapse without evidence, future claims are naturally met with greater skepticism. There's another detail that deepens concern. Despite making some of the boldest claims in the energy sector, Donut Lab has shown very little urgency in addressing criticism. There have been no detailed technical briefings, no invitations for independent labs to test the battery. No effort to clarify contradictions between public statements and CES displays. Instead, the company continues to rely heavily on promotional language and carefully framed announcements. That approach might work in software or consumer tech. But in battery science, it sends the wrong signal. Revolutionary technologies are normally accompanied by a flood of data, patents, measurements, and third-party confirmations. Silence, in this context, doesn't protect intellectual property. It amplifies doubt. And by this point, skepticism was no longer limited to online commenters or a few engineers. Industry observers began asking a much more direct question. If Donut Lab truly holds a battery capable of reshaping transportation, energy storage, and global supply chains, why does the company behind it look so unprepared for the scale of what it claims to have built? And that question leads directly to an even bigger mystery. Because as people tried to understand what this battery actually was, they ran into something far more unsettling. No one could get a straight answer. At this point, the controversy surrounding Donut Lab had moved beyond performance numbers and company background. The conversation shifted to something far more fundamental. What exactly is this device? Despite repeatedly marketing the product as a solid-state battery, Donut Lab has never clearly explained what that actually means in their case. There has been no definitive public statement describing the electrolyte, the internal structure, or even the basic classification of the technology. When journalists and industry analysts asked directly whether the product was a true solid-state battery or a different type of energy storage system, company representatives refused to give a straight answer. The justification was always the same: competitive advantage, trade secrets, protection of intellectual property. That explanation only goes so far. In the battery industry, it is completely normal to protect formulas and manufacturing processes. What is not normal is refusing to confirm what category of device you are selling. A serious company can clearly say, "This is a solid-state battery," without revealing a single proprietary detail. That refusal raised an uncomfortable possibility. What if this isn't a solid-state battery at all? Many experts began pointing out that Donut Lab's most dramatic claims, ultra-fast charging and an extremely long cycle life, fit much more naturally with another technology entirely: supercapacitors. Supercapacitors are known for charging in seconds or minutes and surviving tens or even hundreds of thousands of cycles with minimal degradation. In those areas, they outperform traditional batteries by a wide margin. But they come with a major drawback. They have far lower energy density. That's the trade-off. Always has been. So if Donut Lab's device behaves like a supercapacitor in terms of charging speed and lifespan, but is being marketed like a battery in terms of range and energy storage, the contradiction becomes obvious. You can't have both, at least not with known physics. This has led to growing speculation that Donut Lab may be playing a game of definitions. By loosely labeling the technology as a solid-state battery, they gain credibility and excitement. By avoiding clear technical classification, they avoid direct comparisons that would expose inconsistencies. And this ambiguity isn't a small detail. If the device is closer to a supercapacitor, then claims of 5-minute charging and extreme durability suddenly make sense. But claims of 400 watt-hours per kilogram, long-range electric vehicles, and industry-leading energy storage begin to fall apart. On the other hand, if it truly is a solid-state battery, then the refusal to clarify its basic design becomes even harder to justify. Because a real breakthrough doesn't hide behind vague language. It stands up to scrutiny. By this stage, skepticism had reached a tipping point. What began as excitement turned into confusion, and confusion turned into suspicion. People weren't just questioning how good the battery was anymore. They were questioning whether the battery being described actually existed at all. And that growing doubt soon caught the attention of players far bigger than Donut Lab. Up until this point, most of the criticism surrounding Donut Lab could have been dismissed as online skepticism. Engineers questioning numbers, analysts asking for data, comment sections filled with doubt. But then something happened that changed the tone of the entire conversation. The pushback went public, and it came from the very top of the battery industry. Rico Ulysses, a senior executive at CATL, the world's largest battery manufacturer, took to LinkedIn and described Donut Lab's battery claims as clearly false. That wasn't a careful corporate statement. It wasn't vague or diplomatic. It was blunt. In an industry where executives rarely comment on competitors, especially small startups, this was extraordinary. CATL has spent decades and tens of billions of dollars developing real, commercial battery technology. They supply cells to some of the biggest automakers in the world. Their engineers live inside the limits of physics, chemistry, and manufacturing reality every day. For someone at that level to publicly dismiss a new technology sends a powerful signal. Because CATL has no incentive to attack a small company. If Donut Lab truly had a scalable solid-state battery with double the energy density of lithium-ion cells, CATL wouldn't mock it. They would study it. They would pursue licensing. They might even move to acquire the company outright. That's how real breakthroughs are treated. The fact that a CATL executive chose to issue an outright denial suggests something very different. It suggests that, from an expert's perspective, the claims don't merely look optimistic. They appear to contradict well-established scientific constraints. And CATL wasn't alone. Other industry observers quietly echoed the same doubts. The absence of partnerships with major automakers or established battery manufacturers became impossible to ignore. No Toyota, no Volkswagen, no Hyundai, no energy storage giants, no long-term supply agreements. Instead, Donut Lab's first major demonstration partner was a small electric motorcycle manufacturer with limited production volume and relatively low revenue. From a business standpoint, that choice makes little sense. If you truly possessed a world-changing battery, global corporations would be lining up to evaluate it. They would demand extensive testing, independent validation, and contractual guarantees. Working with a niche manufacturer avoids that level of scrutiny. And scrutiny was exactly what Donut Lab seemed to be avoiding. As pressure mounted, the company did not release new data. There were no third-party lab results, no university collaborations, no standardized testing reports, just continued marketing statements and reaffirmations of earlier claims. In science and engineering, silence at this stage is dangerous. Because revolutionary technologies don't survive on confidence alone. They survive on replication, on verification, on others being able to confirm the results independently. By the time CATL's response entered the picture, the Donut Lab story had crossed a critical threshold. It was no longer just a startup making bold promises. It had become a case study in how extraordinary claims attract extraordinary scrutiny. And that scrutiny was about to uncover yet another uncomfortable layer of the story, one that raised questions about where this technology may have actually come from in the first place. As doubts around Donut Lab continued to grow, attention shifted in a new and unexpected direction. Some researchers and industry watchers began noticing that parts of Donut Lab's story sounded familiar. Not similar, almost identical. Independent analysts pointed out that the technology Donut Lab was presenting closely resembled earlier research tied to a Finnish company called Nordic Nano. Unlike Donut Lab, Nordic Nano has been operating quietly for years, focusing on nanomaterials and advanced energy storage concepts, often in cooperation with academic institutions in Finland. That alone wouldn't be unusual. Collaboration is common in this field. But what raised eyebrows was how closely the descriptions aligned, especially when it came to material behavior, temperature tolerance, and long cycle life. Then came the paperwork. Business registration records filed in Estonia revealed that a company affiliated with Donut Lab had signed technology transfer or technical cooperation agreements with Nordic Nano. The existence of these agreements is not disputed. What remains unclear is what they actually cover. Who developed the core technology? Who owns the intellectual property? And how mature is the technology being marketed? Those questions remain unanswered. What makes this situation more troubling is the silence that followed. When journalists and analysts reached out to Nordic Nano for clarification, asking whether the technology was truly a solid-state battery, whether patents existed, and how performance was measured, the responses were minimal or non-existent. Donut Lab, for its part, offered no clarification either. In technology marketing, silence can sometimes be strategic. But in science and engineering, especially when world-changing claims are involved, silence is almost always interpreted as weakness. If the technology were fully developed, independently validated, and ready for mass production, this would be the moment to show it. Publish test results. Reference patents. Invite third-party verification. It's the kind of claim that could rewrite the energy industry overnight. But extraordinary claims require extraordinary evidence, and there is none. No working prototypes were shown. No third-party validation exists. Energy density numbers shifted without explanation. The company refused to clarify basic technical details. The team behind it is tiny, with limited battery expertise, led by a CEO whose history is filled with bold claims that failed to materialize. Even the largest battery manufacturers have publicly cast doubt. The pattern is unmistakable. Hype without verification, promises without proof, silence when scrutiny arrives. Add in the unclear connection to Nordic Nano, the ambiguity around intellectual property, and the lack of mass production evidence. And what started as a story about a revolutionary battery turns into a cautionary tale about trust, transparency, and scientific rigor. Solid-state batteries remain one of the most challenging technologies ever pursued. Even decades of research by the largest companies have yet to overcome the fundamental obstacles of solid electrolytes, interface stability, and scalable manufacturing. Until independent labs, credible institutions, or Donut Lab itself can provide clear, verifiable evidence, skepticism isn't just reasonable, it's necessary. So the next time a small startup claims to have solved every problem at once, remember this story. Innovation isn't measured in promises. It's measured in proof. And right now, Donut Lab's battery exists more in headlines than in reality. The question isn't just whether Donut Lab is overhyping their battery. It's whether the world is ready to believe something that sounds too good to be true. Because sometimes, when a story seems perfect, the truth is far more complicated and far more important to uncover.